Welcome to springlib.
We want to describe how the graph of f of x is equal to x times the square root of c squared minus x squared varies as c varies. Then we want to graph several members of the family to illustrate the trends that we discover. And in particular, we want to investigate how the maximum, minimum points and inflection points vary as c varies. And we want to identify any transitional values of c at which the basic shape of the curve changes. So first, something we might want to do is figure out what our domain of this function is going to be, and also identify our x-intercepts. So first, let's just find the domain. So I'll do it off on the side here. So domain, well, we need to make sure that c squared minus x squared is going to be greater than or equal to 0. Well, we can go ahead and add x squared over, so we get c squared less than or equal to x squared. And when we square root each side, we end up with c. I should actually put the absolute value of c is less than or equal to x less than or equal to the negative absolute value of c, since we don't know if c is going to be positive or negative. So at least we know our domain is going to be those values there. And now let's go ahead and figure out our intercepts. So we can go ahead and set this equal to 0. So that tells us either x is equal to 0 or the square root of c squared minus x squared is equal to 0, which would be the same thing as just c squared minus x squared is equal to 0. And following pretty much the same thing, that will tell us that x is going to either be plus or minus the absolute value of c. And since we have that absolute value, we can really just write it as x is equal to plus or minus c. All right, so we know our x-intercepts. We know our domain. And one thing we should also notice is that c cannot equal to 0 for any value. Because if it is, we end up with x square root of negative x squared, and x squared is always going to be positive. So I'm always taking the negative of a square root, or I'm always square rooting something that is negative, which is undefined. All right, so we at least got all of the information out of just f of x that we can extract, or at least I think we can extract. So let's go to the first derivative. So f prime of x is going to be, well, we're going to need to use product rule to take this derivative. So taking the derivative of our first function, x would just give us 1. So it would be c squared minus x squared plus x times the derivative of the square root. So we're going to need to use chain rule for that. So we'd still have the x, and then it's going to be 1/2 1 over the square root of c squared minus x squared. Then we take the derivative on the inside, which is going to be, well, the derivative of c squared is going to be 0. Negative x squared becomes 2, or negative 2x. Notice these 2's here can cancel out, and those x's just become x squared. So let me go ahead and rewrite this. C squared minus x squared plus x squared over c squared minus x squared square rooted. Now let's go ahead and add these into one fraction. So I would need to multiply the left by the square root of c squared minus x squared, which would just be c squared minus x squared in the numerator. Oh, and I almost forgot my negative right here. So then negative x squared all over the square root of c squared minus x squared, and then that simplifies to c squared minus 2x squared over, let me zoom out, c squared minus x squared square rooted. Now, if we were to set this here equal to 0, well, we just set the numerator equal to 0, and that would tell us that c squared is equal to 2 times x squared, square root, or divided by 2, then square rooting each side, we get x is equal to plus or minus c squared over 2. And if we want, we can rewrite this again as just plus or minus c over the square root of 2. And so this here will be within our domain. since c will be at least within our domain, and then dividing it by a positive number will also keep us in our domain. All right. Then let's look at the second derivative. So I'm going to use this one here to take the derivative. So we're just going to use quotient rule. So remember, quotient rule says low d high. So we're going to have c squared minus x squared square rooted. Then the derivative of our numerator. So that's just going to be negative 4x, and then minus them in the opposite order. So c squared minus x squared times the derivative of the square root of c minus x squared. And we already found that from right here. So that's just going to be x over the square root of c squared minus x squared negative, and then all over what we have in our denominator squared. So it'll just be c squared minus x squared. And then if we were to just go through and do that algebra, we should end up with 2x cubed minus 3c squared x all over c squared minus x squared to the 3 half. And then if we set this equal to 0, well, we just set the numerator equal to 0. So that's really just asking for us to solve for 2x cubed is equal to 3c squared. Oh, actually, let me go ahead and factor an x out first. So 2x squared minus 3c squared is equal to 0. So by the zero product property, that tells us either x is equal to 0 or this other expression is equal to 0. So 2x squared minus, or let me just go ahead and do equals 3c squared divided by 2 square root, and we get x is equal to plus or minus 3c squared over 2 square rooted. And again, let's go ahead and pull that c out with absolute value, but the plus or minus makes it so it doesn't really matter. So we get plus or minus c times the square root of 3 over 2. Now, notice that the square root of 3 over 2, so let me write this on the side, square root of 3 over 2 is strictly larger than 1. So if it's positive, it's going to be strictly larger than the absolute value of c. And if it's negative, it's going to be strictly less than. So this here is actually not in domain. So if we have an inflection point, it's only going to be at x is equal to 0. All right, so I think this is all the information we can really pull out from this. Oh, and maybe over here I should say that the reason why we're doing this, remember, is to find our possible maximums and minimums. All right, so I went ahead and graphed a handful of these for varying values of c. And so our zeros end up being where we expect them to be. So at plus or minus whatever the value for c is, and at 0 in each case. So at c is equal to 1/2, we get it at negative half, half, and 0. C is equal to plus or minus 1, negative 1, 1, and 0. And for c is equal to plus or minus 5, we get 0 and negative 5 and 5. Now our maximums and minimums are all pretty much where we would expect as well. So if we divide 1 by the square root of 2, well, that's going to be about 1.8. So that's about where that's be, and the other ones are about the same as well. We have our inflection point at x is equal to 0. So it looks like everything we have pretty much matches up with what we got from the first part.